Hey there, physical science students. This is Ms. Ruark again. All right, now that we know how to name the compounds and identify them, let's learn how to write the formulas for these compounds. So, let me get good color. All right, let's review. An ionic compound is something that starts with a metal, and it's going to contain, it either has a metal and a nonmetal, or it contains those things that I talked about before called polyatomic ions. Okay, well, what is a polyatomic ion? Well, we're going to get into that in just a minute. All right, so to write the formula for an ionic compound, first you have to find the charge of the ions. Okay, the charge of the ions. And then you're going to cross down the charges to get the subscripts. And then the last step is to simplify the subscripts. Okay, sounds pretty easy, right? 3 steps, 1, 2, 3. Let's try this. Okay, looking at your periodic table, calcium is in group 2, so calcium has to have a positive 2 charge. And oxygen is in the oxygen group, group 16, and they have negative 2 charge. Okay, these are going to cross down, so we end up with Ca2O2. However, when you have an ionic compound, metal first, you have to simplify. And so we can take out a greatest common multiple of 2, and we end up with a CaO. So we did our 3 steps. Number 1, we found the charge. 2, we crossed them down to get the subscripts, and then 3, we simplified. All right, let's try another one. So lithium is in the group 1, so it's going to have a charge of +1. And nitrogen is in group 15. It has a charge of -3. All right, we're going to cross those down. Right, cross them down, and we end up with Li3N1. Now, we don't ever write ones, so we're going to drop that. We're going to simplify it to Li3N. All right, so if you're thinking that you've got this, go on ahead and try. Pause it, try the next 3, and come back and check your work. All right, aluminum, Al, and it's in the boron group, so it has a charge of +3. And then chlorine is a halogen. It has a charge of, all the halogens have a charge of -1. Okay, cross those down, and you end up with Al1Cl3, and we're going to drop that 1, so we end up with AlCl3. All right, strontium and phosphorus. Strontium is in group 2, so it's got a charge of 2, positive, and phosphorus is under nitrogen, and it's got a charge of 3, negative. Okay, we're going to cross those down. We're going to end up with Sr3P2. Question is, can I simplify that? Well, we can, but we wouldn't have whole numbers, so we're going to keep it just like it is. All right, and then the last one, sodium Na is in group 1, has a +1 charge, and sulfur is under oxygen. It has a -2 charge. We cross those down, we end up with Na2S1, drop the 1, so Na2S. Not too bad, I hope. We'll practice more when you get into class. All right, so what are polyatomic ions? Well, polyatomic ions are many atoms that are bonded together that have a charge. Okay, so some of the ones that you need to make sure that you memorize, and I'll give you a list and we'll talk about them. But like I said, I'll give you a list in class and we'll highlight the ones that you have to know. But you definitely want to know ammonium. Ammonium, not ammonia, ammonium is NH4 with a +1 charge. It's the only cation that we're going to worry about, so make sure you know that. Anions we have, which are, remember, cations are positive charges. Why? Because cats have paws and they're positively marvelous, right? Yes, I know, you remember that. Okay, anions, a negative ion, right? Negative charge. There are many of these. Okay, these are just some of them. So we have hydroxide with a -1 charge. And if there's not a 1 written here, we just assume that the negative means -1. Sulfate would be SO4 with a -2 charge. Nitrate is NO3 with a -1. Phosphate would be PO4 with a -3. Chlorite would be ClO2 with a -1 charge, and then carbonate would be CO3 with a -2 charge. Okay, so these are just, wrote it wrong, sorry. So these are just some, not many. just some, but I'll give you a list in class. All right, so when we do formulas with polyatomic ions, first you've got to find the charge of the ions. Okay, same as always, same as last ones. Okay, and then the next thing you want to do is you want to put parentheses around the polyatomic ion. Now, if you haven't been able to figure it out by now, I am a huge Star Wars fan. I love sci-fi. Okay, if you haven't been able to figure it out yet, I don't know how, but okay, so think force fields. The parentheses goes around the polyatomic ion. It acts as a force field. That way nothing can get inside. Okay. Then we're going to cross down the charges to get our subscripts, same as last time, and then we simplify our subscripts. But we only simplify what's outside of the parentheses. So make sure you write that down. Outside parentheses. All right, make sure you know that. Okay, so calcium hydroxide. Calcium is in group 2. It has a positive 2 charge. And hydroxide is OH with a negative 1 charge. All right, so we've found our charges. Now we put parentheses around the polyatomic ion. So put parentheses around it. Okay, now we can cross down our charges. That goes there, that goes there. Okay, so we end up with Ca1. Keep your parentheses, OH in parentheses with a 2. We don't need the 1, so we drop it, and we end up with CaOH2. Now, we keep the parentheses if the number outside the parentheses is a 1, if it's a 2 or greater. If it's a 1, you can let it go away. But if it makes you feel good, you can write it. All right, so lithium sulfate. Lithium is +1 because it's in group 1, and sulfate is SO4 with a 2- charge. Okay, so we've got our charges of our ions. Next thing we do is put parentheses around the polyatomic ion, cross them down, and we end up with Li2SO4 in parentheses with a 1. Now remember what I said, the 1 goes away, so we can let these go away as well. So it would end up being Li2SO4. The only time you need the parentheses is if this number back here is greater than 1. All right, ammonium carbonate. So ammonium is NH4 with a positive 1 charge, and then carbonate is CO3 with a negative 2 charge. Okay, put parentheses around the polyatomic ion. Guess what? There's 2. So yes, you're going to put parentheses around both of them. Yes, both of them. All right, 1 and 2 cross down. We end up with parentheses NH4, close parentheses 2. Parentheses CO3, close parentheses 1. Okay, the 1 goes away, so what's going to happen to these parentheses? They're going to go away. So NH4 in parentheses with a 2, CO3. All right, barium chromate. This one, barium is a positive 2 charge, and chromate, CrO4 with a negative 2 charge. Okay. Put parentheses around your polyatomic ion. Your 2's cross down. So we end up with Ba2 parentheses CrO4 close parentheses 2. Okay, now simplify your subscripts, only the ones outside the parentheses. So the 2 and the 2, greatest common multiple that comes out of those, or greatest common factor, would be 2, so it ends up being BaCrO4, and you can lose the parentheses, so BaCrO4. All right, last one, aluminum and phosphate. Aluminum has a positive 3 charge. Phosphate is PO4 with a negative 3 charge. Okay, now some of you might say, hey, guess what? Those are the same numbers. They're gonna cancel each other out. And if you see that, great, you're one step ahead of the game. If you don't, it's okay. Let's go through the steps. Parentheses around the polyatomic ion, cross them down. We end up with Al3, parentheses, PO4, close parentheses 3. See, those are going to simplify and cancel. And if this becomes a 1, what happens to my parentheses? Well, we can get rid of those too. So aluminum phosphate is Alpo. It's dog food. No, I'm just joking. The name Alpo is a dog food, but aluminum phosphate is not. Okay, covalent compounds. These are going to be pretty easy. So Covalent compounds, it should say starts, not stars. Starts with a non-metal. And you can always tell if it's a covalent compound because 1, it has a non-metal, and 2, it has prefixes in it. Yes, prefixes. All right, remember, prefixes tell how many atoms of each element there are. So let's try these. We have oxygen disulfide. Now, if there's nothing written on this first one, we say it's just 1. So there's 1 oxygen and there's 2 sulfurs. So now we're going to write this as OS2. And that's it. There's no crossing. Don't cross your subscripts. That only happens if it's charges. All right, let's try the next one. Phosphorus. So there's just 1 phosphorus. Pentoxide. Pent is 5. Oxide is oxygen. So PO5. And I think I wrote the name wrong because it was supposed to be diphosphorus pentoxide, but I wrote it wrong. So, oh well. All right, let me write that in there because that's really going to bother me. Diphosphorus, 2 phosphorus, pentoxide, 5 oxygens. Sorry. All right, sulfur dioxide. Sulfur is just 1, so we put the S. Di means 2, oxide means oxygen, so SO2. Remember, don't cross on these. Carbon monoxide, 1 carbon, 1 oxygen. And then on this last one, sulfur, S. Hexa is 6, fluoride is F, so S, I was going to write it wrong, SF6. And that's it. So I guess I'll see you in class.